Imagine getting into your car, tapping a destination on your phone, and being guided to the exact parking space within a few meters. It feels effortless. But here's the absurd part. If scientists ignored a theory about warped space and stretchy time, a theory that sounds more like science fiction than engineering, your GPS would drift by several kilometers every single day. So why does finding the nearest coffee shop depend on Einstein? At first, that sounds impossible. GPS is just a bunch of satellites sending signals, right? Surely all you need is some accurate clocks and a map of the Earth. Why would a theory about gravity bending space have anything to do with your morning commute? Couldn't engineers simply build better hardware or calibrate the satellites more often? That would seem like the obvious solution. After all, we fix inaccurate watches by adjusting them. We fix software bugs with updates. Why not do the same with GPS? The strange answer is that the clocks aren't malfunctioning at all. They're working perfectly. The problem is that time itself doesn't pass at the same speed everywhere. That idea is so bizarre that even today it feels wrong. Time is supposed to be universal. 1 second should be 1 second, whether you're standing on Earth or orbiting hundreds of kilometers above it. That's how most of us instinctively think about time. In fact, that's how scientists thought for centuries. Then, in the early 1900s, Einstein turned that assumption upside down. His first breakthrough, known as special relativity, revealed that time depends on motion. The faster you move, the more slowly your clock ticks compared to someone standing still. Not by much at everyday speeds, but the effect becomes measurable when objects travel incredibly fast. GPS satellites move at around 14,000 kilometers per hour as they circle Earth. That's fast enough for their onboard atomic clocks to run just a little slower than clocks on the ground. Problem solved then? Just account for that tiny slowdown? Not quite, because Einstein wasn't finished. A few years later came General Relativity, and this one sounded even stranger. Gravity, Einstein argued, isn't just a force pulling objects together. Massive objects like Earth actually warp space and time around them. One consequence is that gravity also changes how quickly time passes. Here's the surprising part. The farther you are from Earth's gravity, the faster time flows. That means the clocks aboard GPS satellites, high above the planet, actually tick faster than identical clocks sitting on Earth's surface. Now things get weird. One effect makes the satellite clocks run slower because they're moving quickly. The other makes them run faster because they're farther from Earth's gravity. So which one wins? Before we find out, thanks for joining me on another journey into the hidden logic behind everyday absurdities. If you enjoy discovering why things that seem ridiculous actually make perfect sense, consider subscribing and let me know in the comments what everyday mystery you'd like us to investigate next. Because the most surprising part of this story isn't that Einstein was right. It's just how much being right matters. The numbers are astonishing. Special relativity slows the satellite clocks by about 7 microseconds every day. That's 7 millionths of a second. Practically nothing. But general relativity speeds them up by about 45 microseconds per day. Subtract the two, and the clocks end up running about 38 microseconds faster every single day than clocks on Earth. 38 millionths of a second doesn't sound like much. You can blink thousands of times before noticing such a tiny interval. But GPS doesn't measure distance directly. It measures how long radio signals take to travel. Radio waves move at the speed of light, about 300,000 kilometers every second. So if a clock is wrong by just 1 microsecond, that's enough to create an error of roughly 300 meters. Multiply that tiny daily timing error, and the position calculated by your GPS would drift by around 10 kilometers every day. Not eventually, every single day. After just a few minutes, the error would already be large enough to send drivers onto the wrong street. Aircraft navigation would become unreliable. Emergency responders could be directed to the wrong location. Surveying, agriculture, shipping, financial networks, and even parts of the internet that rely on precise timing would all begin accumulating errors. GPS isn't really a positioning system. It's a timekeeping system disguised as a positioning system. Every GPS satellite carries multiple atomic clocks so accurate they'd lose only tiny fractions of a second over millions of years. Your phone constantly compares signals arriving from several satellites. By measuring the incredibly small differences in arrival times, it calculates where you must be. The whole system depends on one assumption. The clocks agree. Except they don't. Not naturally. Engineers have to deliberately compensate for relativity. In fact, the satellite clocks are adjusted before launch so that once they're in orbit, moving quickly and experiencing weaker gravity, they tick at exactly the rate needed for users on Earth. The navigation system also includes ongoing relativistic corrections as part of its calculations, because the satellite's positions and motions are constantly changing. What's remarkable is that nobody adds relativity because it's elegant. They add it because leaving it out breaks the system, and that's perhaps the biggest twist of all. When Einstein developed his theories, GPS didn't exist. Satellites didn't exist. Atomic clocks hadn't even been invented. He wasn't trying to solve a navigation problem. He was simply following mathematics and observations to understand how the universe worked. Many people at the time considered his ideas too abstract to have practical value. Even Einstein himself couldn't have predicted that one day billions of people would rely on those equations just to find the fastest route home. There's also a popular myth that GPS somehow proved relativity for the first time. That's not true. Einstein's theories had already been confirmed through many independent experiments. GPS simply became one of the clearest everyday demonstrations that those predictions aren't just interesting, they're unavoidable. And that's what makes this story so fascinating. GPS looks like a triumph of satellites, electronics, and software. In reality, it's also a triumph of physics. Every successful navigation request is quietly confirming that time isn't as simple as it feels. The next time your phone tells you to turn left in 100 meters, remember what's really happening. Tiny satellites are racing around Earth, carrying clocks that experience time differently because of both their speed and their distance from our planet's gravity. An invisible correction based on ideas developed more than a century ago keeps everything synchronized closely enough to guide you almost anywhere on Earth. It sounds absurd that getting directions depends on time itself flowing at different speeds, until you know the story.